Hey, we're going to finish up on elimination problems, and these are ones that were available in the Pear Deck, but I'm also going to walk them through as an ed puzzle instead. So if you did complete them in the Pear Deck, you can disregard this ed puzzle. All right, and this is number 23. I can make connections about the graphs of elimination method problems with unexpected outcomes. So this is the one with the screaming man in the corner, number 7. And here is two equations. They're written in what we call general or standard form. So they're not y equals either of them. And this is a good reason to use elimination. So you're going to look at the two and you're going to decide, what do I want to get rid of? And it doesn't matter. We can either get rid of x's or y's. I'm going to go ahead and get rid of x's. So I want the two numbers to match in front, but I want one of them to be positive and one of them to be negative. So I'm going to try and get them both to be 2. So I'm going to wrap this one up in parentheses. And instead of just multiplying by 2, I'm actually going to multiply by -2. And that'll make it so that one will be positive and one will be negative. Okay, so nothing changes here. It's still 2x plus 6y equals 38. Oops. But everything in here is going to get doubled by -2. So what will be the new line right here once everything is doubled? All right, we're going to multiply everything by -2. Hopefully you said -2x. You said -6y. And a -2 times 19 is -38. All right, so we've got that far. Now this is again the elimination method, but before it was ever called the elimination method, it was called the addition method. It's what we call elimination because you eliminate one of the variables. Which variable are we eliminating? Hopefully you said x. All right, and they always call it the addition method because you add them straight down. So 2x plus -2x is a 0x, but that makes this all disappear. So that's eliminated. And then, so I'm going to just write, just for my own sanity, I'll write 0x. Now I'm going to add this straight down. 6y plus -6y, what does that equal? All right, 0y. And then, this is getting weird, 38 plus -38. And that also equals 0. All right, and then what is 0 times anything? 0. So this is really 0 plus 0 equals 0. And that's true, isn't it? 0 equals 0. And so what we wanted to happen was just eliminate one variable, but instead we eliminated both of them. And so then we have some soul searching to do. So I'm going to jump to a screen that can help us see what that's about. So this is a link for Desmos, and this will take us to the equations we were just working with. They're here, and then I'm going to turn them on. So 2x plus 6y equals 38. That's a red line. And now I'm going to turn on x plus 3y equals 19. And what happened? What can we say is true about these two lines? Hopefully you said that they're the same line. Okay, and so back earlier in the chapter, we talked about in one of our I can statements that if the two lines are the same, then what did we discover about how many solutions they have? Hopefully you picked that they have an infinite number of solutions. All right, so that's how that one ends. We say they are the same line. So there are infinite number of solutions. Today's day and age, you can graph them and confirm that. When I was in high school, we didn't have decimals.com where we could look at it. All right, so that's why there was the screaming man for this one, is because we did this work and it came out to 0 plus 0 equals 0, which is true, but that all happened because it's really the same line. Okay, there's a second scenario we're going to look at, one more here, and this one is going to be 3x plus 5y equals 39, 3x plus 5y equals 26. And so just in the spirit of continuity, let's again get rid of the x's. And it doesn't matter which one we multiply, but they're really close to done except for they're both positive. So what do we need to multiply this top one by to make it negative? Hopefully you said -1. And now we're going to distribute that. Everybody gets times -1. So what will be the new statement written right here? Hopefully you said -3x minus 5y equals -39. All right. The next one doesn't need to be changed at all. So we're going to just recopy it here. 3x plus 5y equals 26. All right, so this is the elimination method. We're trying to get rid of one variable. Before it was ever called elimination, it was called the addition method. So we'll add straight down. -3x plus 3x equals what? Okay, 0x. -5y plus 5y is what? That's right, 0x. And -39 plus 26. And you should get -13. All right, this is disheartening. What's 0 times anything? 0. So 0 plus 0 equals -13. And how often does that happen in your life, that 0 equals -13? I don't know if you've seen one of these before, but 0 does not equal -13. So you put a little line through that says 0 is not equal to -13. All right, so we're going to go ahead, and you can only imagine that I also have the link for that one. So we can take a look what that graph looks like. All right, so we've got it up. I turned the first one on. Looks like that. And then I turn the second one on. It looks like that. How would you describe these two lines? Hopefully you said they're parallel. And when they're parallel, do they ever cross? Nope. So how many solutions are there? And hopefully you said there are no solutions. So when we're looking at this question, if you get a situation like this where 0 equals some other number, not 0, this is your tip off that these lines never cross. So 0 never equals -13, which means the lines never crossed. They are parallel. How many solutions are there? There are no solutions. All right, so this is the end of the pear deck from last week, but we're giving it a new I can statement. I can make connections about the graphs of elimination method problems with unexpected outcomes. And there you go.